Welcome to our exploration of the crawler log folder problem from Leetcode. This problem, number 1598 on Leetcode, is all about navigating through a file system using different operations. We'll break it down and make it easy to understand. Let's break down the problem and understand what we're dealing with. Imagine a file system that tracks your folder movements. You can move up to the parent folder, stay in the current folder, or move into a child folder. These operations are represented by /, and x/ respectively. Now, let's look at some examples to better understand how this works. In our first example, we have a series of operations, moving into D1, then D2, going back up, moving into D21, and staying there. After these operations, we end up in folder D21. To get back to the main folder, we need to go up twice. So the answer for this example is 2. So, what exactly are we trying to find in this problem? Your task is to analyze these logs and determine how many steps are needed to return to the main folder. It's similar to tracking your movement up and down stairs, where / is going up, / is staying put, and x/ is going down into a new room. Let's summarize what we've learned about this problem. This problem simulates a stack-based navigation system for folder structures. The key is understanding how each operation affects your position, moving into a folder, staying put, or moving up. By tracking these movements, you can calculate the steps needed to return to the main folder. Once you grasp the concept, it becomes quite straightforward. Here is a visualization of the crawler log folder problem. Our input logs are D1/, D2/, /, D21//. Step 1, D1. Here is the solution explanation of the crawler log folder problem. We'll go through the problem step by step and then look at the Java code that solves it. I strongly encourage you to code along. Start in the main folder, depth equals 0. Process each operation in logs. If /, move up a folder, depth equals 1, but not below 0. If /, stay in the current folder, depth unchanged. If x/, move into a child folder, depth plus equals 1. Final depth represents the operations to return to the main folder. Now, let's look at the Java code that solves this problem. We'll go through each important part of the code. We start by initializing the depth to 0. Then we process each log operation in a loop. If we encounter / and the depth is greater than 0, we decrease the depth. If the operation is not /, we increase the depth. Finally, we return the final depth, which represents the number of operations needed to go back to the main folder. This concludes our explanation of the crawler log folder problem. Thank you for watching. Please subscribe to Swecodes if you like to see more of these coding tutorials.